This is the demonstration video for parametric modeling. There are a lot of ways you can use and leverage parametric modeling within our CAD systems. We are going to focus on what I hope is the most straightforward way for you to understand what parametric modeling is and how to utilize it within your designs. And so what we're going to build in this particular demonstration is a prism, and we're going to use the parametric modeling right inside the design itself, as opposed to going into the modify panel, although I am going to show you the modify panel where you can add user parameters and so forth if you want to. So let's go ahead and create a new sketch, and we're just going to put a rectangle on here. So we're just going to be drawing a simple prism. So this is a rectangle. Notice it's got certain geometric constraints on it already. And what we are going to do is build the parameters into the actual design. So when I go here to my dimensioning tool, I'm going to take my length. Okay, and you'll notice when I hover over that, notice that it says D1. That's actually an automatically assigned Fusion parameter. So when you're putting features and sketch entities into your designs in Fusion, it automatically assigns a parameter name to it. In this case, D1 for dimension value. We're going to assign it something else. We're going to assign this L for length, and we're going to make this 5 inches. And notice that Fusion allows me to do that. So what I have done there is not only have I dimensioned that to be 5 inches, I've also assigned it a name. This is L, and L is 5. Okay, so I go in, and now my length is dimensioned at 5. Now I have this width dimension, and I could dimension that width independently, but suppose I want my width of my rectangle to always be 2/3 of the length. So I know, like, for whatever my design is, I know that that's the relationship between the sides that I want. So what Fusion is going to allow us to do, instead of putting a number in there, Fusion is going to allow us to actually put in a mathematical relationship. So we have 2L, okay, and I want to make sure, actually I had to do 2 times L earlier, like it didn't let me do 2L. So 2 times L, and we're going to be using that, and then we're going to take that number and divide it by 3. So take a moment if you need to mathematically and convince yourself that that is 2/3 of L. Okay, and notice this little f of x that pops up. That is letting us know that this particular dimension is defined in terms of another dimension that we have on our diagram. And so you'll notice that the width of my rectangle here is now 3.333 inches, and that f of x is telling you this was parametrically defined. This is not actually dimensioned at 3.333 inches. It is defined in relation to something else. Now, here's the cool thing about parametric modeling. Just like with the geometric constraints, if I go in and I change this dimension, so let's say I make this 6 inches, remember that my other dimension on my rectangle is supposed to be 2/3 of whatever I have defined as L. And when I change the length to 6, notice my width automatically updated to 4. And you can do that for pretty much anything, okay? So if I wanted to make this 3, okay, now we have 2, and you can see the relationship there. Now our parametric parameters actually will extend over into our entire design. So once I have that parameter defined, I can now extrude, and I can say extrude to L minus 1. Okay, whatever L minus 1 is. And so again, notice that my extrusion here is parametrically defined. And there's my prism. Okay, now here's the cool thing about parametric modeling. If I go back into my sketches, okay, and I go back and edit sketch 1, and I go change this to, we'll make this 6 again. Okay, we know it updates the sketch. It also, notice it updated my 3D model. So what you will be required to do is something along the lines of what I just did. You are going to design a cam, but you're going to design it with the parameters. And then what you're going to do is go back into your sketch and you're going to edit the original dimension and show in your screencast that everything updates along with it. Now, one more thing to note, if you look in the PLTW curriculum, they take you through a way of doing parameters that is under our modify panel, and way down here at the bottom it says change parameters. So it says display the parameters dialog where you can create and manage equations and relationships to control the size of objects. You can edit the name, expression, and comments for the parameters and so forth. So if I open that up, you will notice that I actually do have a parameter in there. That parameter is named L. I can change the name of that to length. But what you really want to do most of the time is keep them fairly simple, and you want to name them after things that you're going to remember what they are. And you can come in here and edit, your expression for that. I was playing around with this earlier, okay? And if you go down here, notice I mentioned earlier that whenever you add something into your design, it will update, Fusion automatically assigns a parameter name to it. And it just basically says like D1, D2, D3 in the order that you do the things. So they have D2. If I wanted to, I could call that W for width. Oh, that apparently is not valid. Here we go, width. And you'll see the formula that I have in here for that particular dimension, and you can come and edit that here. This over here is just telling you the current values for everything. And then there's my extrude. Okay, and notice again, Fusion automatically assigned it a parameter name that is L-1. So when my original parameter or value here was 6, 2/3 of 6 is 4, 1 less than 6 is 5. If I go back in here and I change this to 10, okay, you can see everything update along with it. And when I go back to my design, you can see that it has updated there as well. So these are the things that you are going to have to demonstrate in your screencast to show that you know what parametric modeling is and that you can do some basic parametric modeling in relation to your automatas. All right, let's go over to Onshape. And what do I have going on over here? You'll notice I have practice with parametric modeling done at 11:36 this morning. I was actually tinkering with several different things I was tinkering with several different things, but let's go into this one. And will it let me go back and delete? Pretty much what I'm wanting to do is just kind of go back and delete that. And you'll notice this over here. This actually might look a little bit familiar. Okay, so what we have here is our blank slate here, and I forget which one I wanted to start my sketch on. So let's make that normal. There we go. So we're going to start the sketch on the the top plane, and we'll do this similar to how we did the Fusion one, but you probably fast forwarded to the video to get here. All right, so I just slapped a rectangle on here. And with Onshape, it is, of course, a little bit different how you set up and use these parameters. So hopefully this goes smoothly, having just done it in Fusion. So I'm going to go ahead and dimension this. And you'll notice that whatever I put on here, like this rectangle is dimensioned at 7.28, blah, 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 blah. I don't care. Okay, now when I go to dimension it, I'm going to hit pound. Okay, so you have to hit the pound, or I guess for you guys, hashtag, and then it's going to say new variable. Okay, and what that is it's saying, hey, do you want to assign a parameter here? And so that's what we're going to do. We're going to name this L, and we're going to call this 5. Okay, so what we're doing is we are establishing this variable L for length, and we're going to make that 5. And now when I hit enter, it Onshape automatically set the length of my rectangle to 5. All right, and you'll notice over here in the browser over here that we now have this variable set up. So we have some of this variable in our design, and that variable is L, and it is currently assigned to 5 inches. Now when I go to dimension the width of my rectangle, I can define the width in terms of L. So I gotta make sure I do this right. So we're gonna do 2 times, and then I have to hit that pound sign. That was driving me crazy earlier. Okay, divided by 3. I'll pause there for a moment, make sure that you are convinced that that will make the width 2/3 the length of the length there. Okay, and then I hit equals, and notice that it automatically updated that to 3.333 there, which is 2/3 of 5. Now Fusion does something here which I really like. Fusion puts in a little f of x there, so that when you're looking at the sketch, you can tell that that was not dimensioned at 3.33. That was actually dimensioned at 2/3. Now, when I go in here, no, I don't want to do that. Just kidding. You deselect that. If I double click on this, I can go and change the value of L. So I'm going to go ahead and make the value of L 6. And I guess we need to go back in and edit that. And notice that it automatically updated my sketch. So I can go and change the whole sketch just by changing the value of L. So it updated L, but you'll also notice that it updated the width. And we can do the same thing. We can go edit that again. We can make that, say, 10. And then apparently I need to go in. It said some constraints are not. Oh, wait a minute. What happened over here? Hang on. Edit. For whatever reason, it updated to 0. Well, that's going to be problematic. No, what happened? Okay, I paused the video for a little bit. I genuinely do not know what happened. I pretty much didn't do anything. I just went in, and now we've got it at the 10 and the 6 point, the 6.667, and just had to click on the dimensions again, and then Onshape updated it. Not totally sure what happened there. So what I hope you can see here is that when we update the original number here, the rest of the sketch that's defined based off of that updates with it. Now, this should extend to our extrusion. So if I take this and extrude it, now that I have this variable defined, we're going to extrude this to pound L minus 1. Okay, and it accepted that, so yay. And then it did not accept it. Oh, did it not? 9 inches, that was fine. That's okay. Why isn't it showing it? Why does this have to happen? Select. find you. Oh, there we go. All right, yay. And you'll notice that that extruded to 9 because I had defined the extrude to L minus 1. So if L is 10, then the extrude will be to L minus 1, which is 9. Now I'm going to go and we'll see how this goes. I'm going to go back and edit that value again. Let's make it 7. And notice that everything changed. So everything scaled back exactly in proportion to how I've defined it. And let's go edit it again. And this time we'll make it bigger. We'll make it much, much bigger. And notice what happened. So this is what you're going to have to screencast, is you're going to have to screencast your cam, but you're going to have to go back and change your original parameter and demonstrate in your screencast that everything is changing the way it is supposed to change. So that's like a little bit big. Let's go and we'll bring that back down to the 6, okay? And you can see that everything changed. Now, one last thing that I do want to show you is over here on the right-hand side, you'll notice that there's something called the variable table. And when I open that table, you will see my variable, okay, L, and the variable type is a number, and I don't know why we can't see like the whole side over there. Like, I think that's description. So the current value that it's set to is 6. You can change it from here. So you can change it to 8 and you can watch it update. That's probably a great way to screencast it, is to just change it from right there. And then you can add a description so that you can remember what L is. So L is the length of the original rectangle that went into the prism. So you can find that there. And I believe you can also add variables here as well that you can then use in your design. But I think it's easier to build them in. The thing that I have to keep remembering with Onshape is you have to put that pound sign in there. So hopefully this video helps. What I would strongly recommend is that you don't just watch the video, but actually do what I did, practice with parametric modeling, actually do this, play around with it before you screencast, design your cam according to the specifications, and then screencast it once you know that you have it working okay. If you have questions, please let me know.